Good afternoon, everybody. Welcome back. Good afternoon, Om, Tamanna, Harshita, Amit, Komalpreet, Asha, Vansh, Gautam, Pavitra, Pranati, Ananta, Varun, Jannavi, Ruhani, Prakriti. A very good afternoon to all of you and welcome back. Last time we discussed about differentiation and today we are going to discuss about integration. Last time, I hope you can put it in the chat box. You found it easy? Yes? Now you can do sums on differentiation without getting worried. Okay? Yes, Madhulika, good afternoon. Vaidehi, Chanchal, Harshini, Amar, Tanvi, Amog, Sandhya. Vaidehi, I'm fine. I hope all of you are also fine and looking forward to this session. Yes. Okay. Cool. So last time we talked about differentiation. When we are talking about differentiation, what are we talking about? We are talking about rate of change. Okay. So what happens when the independent variable changes by 1 unit or a small amount? How does the dependent variable behave? That is what we talked about last time. Okay. So to express the rate of change in any function. Okay. To express the rate of change of any function, we introduced the concept of derivative, which involved a very small change in the dependent variable with reference to a very small change in the independent variable. So as my independent variable changes, how much will my dependent variable change? Okay. Thus, differentiation is the process of finding the derivative of a continuous function. It is defined as a limiting value. That is why you've seen in the first principle. Okay, we talked about limit, okay, as delta x tends to 0, or we in some books you may have h tending to 0, okay, of the ratio of the change or the increment in the function corresponding to a small change in the independent variable as the latter tends to 0. Okay. So now we come to integration. What is integration? Integration is reverse of differentiation. Okay. So with differentiation, we have a function fx, and when we differentiate, what do we get? We get f dash x. Now, when I have already got a function f dash x, I will integrate it to find out what the original function was. Okay. This is just for your conceptual understanding. We'll be doing the sums. I'll just quickly revise the formula for differentiation because, alternatively, especially when we are using the UV rule, there again we have to use differentiation. So it's always better to revise differentiation and integration formulae together. Okay. Also, the PDF is uploaded on the website, on the live sessions website. So over from there, you download it, all the formula for differentiation and integration, especially this file you can download. So in there, and you can write it in your notebook or you can print it out, and then you have to revise it. Especially what happens in integration is there are a lot of formulae, but the good news is that not all, you will not get questions on all of the formulae. Okay. So some formula they may just ask you the integration of so and so is this. So out of the 4 options, you have to select the correct option. So only if you even know the formula, it's well and good. The simple ones on which you will definitely get questions, we are going to do in detail. Okay. The others, the list is also over there. So you can download, and in this particular PDF, you will also have derivative formula as well as integration formula. Okay. Yes, Sandhya, very cool afternoon. Yes. Yes, Om, thank you for the flowers, stars. Namaste. Dhruv, Chanchal, Sahana. Yes. Tamanna, you've understood. Gautam, Varun is clear. Yes. Amar, very nice. You practiced 2 times and now you're finding it easy. That's the spirit. That's what I want each one of you to do. Okay. Or the thousands of you who are watching this video, please do that. Dipanshu, okay, I'll see. Tisha, good afternoon. Deepika, Varun, good afternoon. Bhumika, good afternoon. Yes. Saloni and Bunny. Okay. Janavi, just go to the website. The notes are there. Just check. Okay. Now d by dx of x raised to n is, we are doing this differentiation, n x raised to n minus 1. Then we have d by dx of e raised to x. What was that? The derivative of the exponential function is the exponential function e raised to x. But if you have d by dx of e raised to ax, what does this mean is, suppose I have e raised to x and suppose I have e raised to 2x. If I have e raised to x, I will use this formula. If I have e raised to 2x, I will use this formula. Clear? There is no much difference, but for you to understand, because there are so many alphabets also coming, so you don't know why these alphabets or what they mean. So it simply means that way. In this case, it will be a e raised to ax. Okay, so this a is addition. Here you have e raised to x, so you have only e raised to x. Here you have a e raised to ax. Okay, derivative of a constant is always equal to 0. Okay, then we have d by dx of a raised to x. As I told you, a raised to x is not same as x raised to a. Okay, and a raised to a is also very different. For example, I have 3 raised to x. Okay, for this formula is applicable. D by dx of a raised to x is a raised to x log a to the base e. Remember, it's a natural log. So if I have d by dx of 3 raised to x, it will be equal to 3 raised to x as it is and log 3 to the base e. Okay. What about this? A raised to a means 3 raised to 3. What is 3 raised to 3? It is a constant, right? Because what is 3 raised to 3? 3 3s are 9, 9 3s are 27. So 27 is a constant. So what will be d by dx of 3 raised to 3? It will be 0. Okay. So I hope all these formula you are able to understand. And the one very important one that we always use, d by dx of log x is equal to 1 upon x. Okay. Clear till now this function, this formula? So from there we come to the integration formula. I think after this you will have your logical reasoning also. Okay. Yes. Yes, Asha. Thank you. Yamini, good afternoon. Sia, good afternoon. Pavan, good afternoon. Priyadarshini. Yes, Rini has also practiced formula thoroughly. Very nice. Asif, good afternoon. Harshita. Clear, Akshata? Prem, yes, clear. Okay. So now let us move to the formula for integration. What is the sign of integration? Integration, it is a elongated S sign. Okay, so this is, quite a few of you have already done this in your 12, but it is good to practice, isn't it? Anyway, integration of x raised to n dx is equal to x raised to n plus 1. Okay, in differentiation we did minus 1. Here it will be plus 1 upon n plus 1 upon n plus 1 plus c. C is which we have to find out. Okay, and here you have to just remember that n is not equal to minus 1. Okay, so that we have to be just careful. That is a formula. Integration of dx means what? If I just have a sign integral dx, this simply means it is equal to integral 1 dx, which is equal to x plus C. Okay. And here integral of e raised to x dx, exponential function, same function will be there, e raised to x plus c. Okay. And like we did for d by dx of e raised to ax, similarly we have integral of e raised to x. So integral of e raised to ax dx will be equal to e raised to ax upon a. There it was multiplied by a. Okay. Yeah. Can you see? It was a into e raised to ax. Here in integration you have e raised to x upon a plus c, which is the constant of integration. Now integral of 1x, 1 upon x dx. Okay. Somewhere this is very important. Okay. This formula. Integral of 1 upon x dx. Sometimes you will see it written as dx upon x. This is equal to log x. This is equal to log x plus c. Why this is important is because this and this are different. Okay. X raised to n. You can even have something like this can also be written as integral of x raised to minus 1 dx. So you may be tempted to use the other formula, integral of x raised to n. But for 1 upon x, the formula is what? For 1 upon x, the formula is integral of 1 upon x is log x. Integral of a raised to x dx is equal to a raised to x log a to the base e plus c. Integral of a raised to x dx is equal to a raised to x log a plus c. Okay. Okay, I will check, or maybe you can check at night. Tonight, maybe the PDF will be available by that time. Okay. Yes, Pankaj Gupta, you can start from here because today we are doing integration. So you can always join and you can always watch the earlier videos for this batch number 7. So all your syllabus will be covered. Okay. Yes, Rohani, you've done in class 12. Tamanna, you can't hear my voice? Ashok? अशोक आवाज नहीं सुनाई दे रही है now you can hear just put it in the chat box can you hear now everything is fine now yes thank you yeah okay now let us go to the sums okay so these are the sums from the textbook that I'm taking what I recommend is that whenever you're solving the question just write the question also we have this usual habit of just reading the question and writing it in the solving it in the notebook or on a piece of paper what I suggested write that question also and in front of that write the formula that you're going to use that way it fits into your memory okay that's a very good shortcut that I'm trying to tell you is your audio visual memory is enhanced that way okay and while you're writing also speak it Okay, I'm saying integral of root x dx is, and I'm using the formula integral of x raised to n is equal to x raised to n plus 1 upon n plus 1. Okay, when I say that, so I have heard my voice also, and when I'm writing, I'm able to see also. And when I want to revise, okay, I just have to see, acha, this type of sum, I have to use this formula. Okay. So for every question here I've written, because I can understand there are a lot of formula, and then in the panic moment I don't remember which formula I have to apply, and when I'm trying to just know before going for the exam, when I want to revise, I simply have to see, okay, this type of sum I'm going to solve it with this formula. Okay, and also remember that x root can be written as x raised to half. Okay, you have cube root of x is written as x raised to 1 by 3. Okay, and anyway, you may have seventh root of x, you will write it as x raised to 1 by 7. Now, what happens if I have cube root of, if I have square root of x cube? Then this will be written as x raised to 3, this as it is upon 2. The square root sign will be upon 2. Okay, so just remember this also. So, something went into my eye. Okay, so I have integral of square root of x dx. Integral of x dx is equal to integral of x raised to half dx. Okay, simply instead of the square root sign, I've written it into value. So, what is my n? N is equal to half. Okay, so I will be using this formula. So the answer will be integral of square root of x dx is equal to integral of x raised to half dx, which is equal to x raised to half plus 1 upon half plus 1 plus c. Now half plus 1 is 3 by 2. We already know. So x raised to 3 by 2 upon, only initially you will have to, like, think about all this, and then you don't have to. Then you will start directly doing the sums, these ones, especially x raised to n. Yes, Palak doing this for the first time. So I hope I'm going slowly enough. Yes, Prayukta, it is C is the constant of integration. Okay, when we have finite integration, so that time we are able to find the value of C, and then we are able to find the graphs. Okay, the equation of the graph. Yes, Akshata understood. Harshita. Yes, Asif, C is the constant of integration. Now, Bidisha, you have very simple, very to the point questions here. So only that type will be coming. Don't worry. Yes, Prakriti, very good. Deepika, there is no question of remembering. As you practice, you will automatically see. Once you see that algebraic expression, you will be able to quickly decide which formula to use. But it requires practice. Okay. Asha, please check your internet connection. Okay. And Deepika, once this live session ends, then you will be able to go back and see. Okay. Anand, don't worry. Oh, very good. Even though you're not a math student, you are able to understand. That's excellent. Okay. Don't worry, Deepika, we are doing more sums like this. You will be able to catch up. Okay. This sum is similar to the earlier sum. Now, this is what 1 upon root x. Okay. Now, if I have 1 upon root x, this means what? 1 upon x raised to half. Okay. Now, something is in the denominator. If you remember, a raised to minus m is equal to 1 upon a raised to m. You've done in indices. So using this is becomes what? This becomes x raised to minus half. Okay. Once I do that, I will write integral of 1 upon root x dx is equal to integral of x raised to minus half dx. And when I use this, so what is my n? N is equal to minus half. So this will become, this is equal to x raised to minus half plus 1 upon minus half plus 1. X raised to minus half plus 1 is half, x raised to half. And what will this be? Minus half plus 1 will again be half. Again, flip. Okay. And what will I get? This is equal to plus c. This is always plus c. This is equal to 2 x raised to half plus c. Now, x raised to half. You may sometimes get the option like this only, or you will get 2 root x plus c. Okay. So, either of this, the answer may be in this form or this form. Both are equally correct. Deepika, I hope you are able to understand now. Tanu, 80% is very good in your 12th standard. There is no need to worry. Okay, and becoming chartered accountant has nothing to do with how much you get in your class 12th. It is upon how much you are able to study well, how much your fundamentals are clear. Okay, so go back to your class 12th textbooks, solve them once again, get all your doubts clear. Especially even your 11th standard books are very good. So 11th and 12th CBSE books you can take up, and then you solve everything over there so that none of your concept remain unclear, and then you study from the study material of the institute. So that becomes easy, and then you can become a CA. 80% is very good marks. Okay, now let us go to we talked about the algebraic functions. Now we are talking about the exponential functions. Okay, so integral of e raised to minus 3x is equal, so we are using the formula integral e raised to x dx is equal to e raised to x upon a plus c. So what is my a? A is equal to minus 3. So integral of e raised to minus 3x dx is equal to e raised to minus 3x upon minus 3 plus c. Okay, so this is equal to minus e raised to minus 3x upon 3 plus c. Okay, so now a raised to x formula. So I have, what is my a here? A is equal to 3. So integral of 3 raised to x dx is equal to 3 raised to x upon log 3 to the base e plus c. Okay, is that clear? Just if you know those 10-15 formula well with differentiation and integration, you will be able to solve them. Okay, now I have x root x. Okay, so as I was earlier telling you, so how do I write x root x? X raised to 1 into x raised to half. This x is x raised to 1 and x raised to half. This is equal to x raised to 1 plus half, which is equal to 1 plus half. Okay, which is equal to x raised to 3 by 2. 1 plus half is 3 by 2. Okay, so that I have integral x root x dx can be written as integral of x raised to 3 by 2 dx. How much will my n be? N is 3 by 2. Okay, from this formula. So this will be equal to x raised to 3 by 2 plus 1 upon 3 by 2 plus 1 plus c, which is equal to x raised to 5 by 2 upon 5 by 2 plus c, which is equal to 2 by 5 x raised to 5 by 2 plus c. Okay. Yes, Chanchal, Saloni, Deepika, now you understood? Ayush, you want me to explain again? Okay. Yes, Vaidevi, you can do CA with your BCom. You will get very good marks in BCom because you have studied for CA. Okay. Okay. Okay, I will explain this sum again. See, what happens here is, this is that you have to be very clear with your concepts of indices. Okay, that helps in solving sums on differentiation and integration. Because at that time when we were doing like a raised to 0 is 1 or a raised to m into n, all those formulas, that time we just very casually will do the sum and we forget about it. But here you have to recall those. And if you have a little difficulty, go back to the chapter, solve some sums over there, just read through this book, and then you'll start realizing that now you can follow this. Okay. Yes. For Ayush, please pay attention. Now I have something called as, let me change the color, x root x. Now I will write this as x raised to 1 into x raised to half, because this is simple x. X is means x raised to 1, and what is this root x? It means square root, so 1 by 2. Now I will use a raised to m into a raised to n is equal to a raised to m plus n. So this becomes equal to x raised to 1 plus half, which is equal to x raised to 3 by 2. Okay. Once I have that, integral of x root x dx is equal to x raised to integral of x raised to 3 by 2 dx, which is equal to x raised to 3 by 2 upon 3 by 2 plus 1 and 3 by 2 plus 1. Now, what is 3 by 2 plus 1? 3 by 2 plus 1, LCM of 2, 3 plus 2, which is equal to 5 by 2. Okay. So this becomes equal to x raised to 5 by 2 upon 5 by 2 plus c. Now I know that something in the denominator, a fraction in the denominator, this needs to be flipped. So the answer is 2 upon 5 x raised to 5 by 2 plus c. Is that clear now, Akash? Yes, Deepika, thank you. Morning, Akshata, Gagan, crystal clear. Harshita, yes. Rini, Apurva. Sreshta? Sreshta, now you understand? Yes, Mansi, answer was correct. Okay. Chavi, where does answer not match? Hmm? Akriti, you can learn the formula. Easiest way is by doing many sums. The more you solve the formula, you don't have to take out separate time to learn those formula. Because you're using it every day. Yeah. Oh, must put a crystal photo also. Yes, Vaidya, if you remember the formula, it becomes easy, but it is a two-way thing, circular thing. You practice more, then automatically you will remember the formula. Okay? हाँ वाणी करेंगे करेंगे. Okay, now. Okay, I will go more slowly. Okay, yes. Don't worry, don't worry. Just let me know. I know some of you finding it slow, some of you will find it fast. Okay? That's just because. Okay. Shrestha has put in a very basic question. Let me address that. For those who understand, no problem. For those who don't. Okay. Whenever in mathematics, whenever you see the alphabet E, it stands for the exponential function. Okay. See, you can go deep into it, but I don't think that is necessary for you. Just knowing this information is enough. When we use A, B, such letters, it simply means that it is a variable, okay, whose value I don't know, whose value I know. Sorry, value I know. This is true only here because when you have A plus B whole square, there A and B, you are going to put in values, okay? So in integration, when I'm using A, B, it means what? It means like A raised to X means what? I will be given some value for A, okay? Then you have X. X is the independent variable here and Y is the dependent variable, okay? You may use Y, you may use fx, okay? F dash x is the symbol of differentiation, okay? This differentiation, okay? And this stands for integration. Okay, Shrestha? Sandhya, we are using integration, when you want to find area under the curve, okay? Like it has a lot of practical applications. Where it is not possible for you to actually take a ruler or draw on a graph and measure, so that time also you can do that. And there is many scientific applications for this as well. Okay, so now let us go to the next one. Now you have integral of x plus 1 upon x whole square dx. Now what happens here is, when you have this, what you should remember is a plus b whole square. Remember this? What is the formula? A square plus twice ab plus b square. Okay. I'm using this formula. What will my a be? A is equal to x. And what is my b? B is equal to 1 upon x. So a square means what? X square. So x square plus 2 into a into b cancel plus 2 plus 1 upon x square. Okay. So my x plus 1 upon x whole square has become this. Now I integrate integration of x square plus 2 plus 1 upon x square dx. This is equal to integral of x square dx plus 2 integral 1 dx plus integral of 1 upon x square dx. Okay, so I take the dx and so this whole algebraic function, I will individually find the integration. Okay, I will individually find the integration. So this is equal to how much? X square becomes x raised to 3 upon 3. Why? Because 2 plus 1, I'm using this formula, 2 plus 1 upon 3. Now 2 integral 1 dx, 1 dx is equal to x. Okay, we have written over here. Integral dx is equal to x. So we are using this formula. Okay, here I have written. So that is the formula we are using here. Okay. And 2 being a constant, it is out of the integration. So 2 1 dx plus 1 upon x square. Now what will be 1 upon x square? It will be x raised to minus 2. 1 upon x square is equal to x raised to minus 2. So integral of 1 upon x square dx will be equal to integral of x raised to minus 2 dx. What will this be? X raised to minus 2 plus 1. Okay, I am using this formula, x raised to n plus 1. What is n? Minus 2. Minus 2 plus 1 upon minus 2 plus 1. So minus 2 plus 1 is minus 1 and minus 2 plus 1 will be minus 1. So this will be x raised to minus 1 upon minus 1. Okay. And now what will I get from here? This is equal to x cube upon 3 plus 2x minus x raised to minus 1 is nothing but 1 upon x. X raised to minus 1. Okay. X raised to minus 1 is equal to 1 upon x. And we already had this minus sign over here. So I'm getting this plus c. Is that clear now? This is an important sum. I hope everybody is followed. Yes, Akriti, I'll do that. Okay, very good. Most of you understood, but there are a few students. So for them, I'm going to repeat. I have integral of x plus 1 upon x whole square dx. First, I will tackle x plus 1 upon x whole square will be expanded. How do I do that? How do I do that? Using the formula a plus b whole square is equal to a square plus twice ab plus b square. What is my a? A is x. What is my b? B is 1 upon x. So I substitute. So I get x square plus 2x into 1 upon x plus 1 upon x whole square. X square plus. Now this 2 and this 2 will get cancelled. 2 plus 1 upon x square. Now I have found this expansion. What is this? This is equal to x plus 1 upon x the whole square. Now I will use that. So I get this to be equal to integral of x square plus 2 plus 1 upon x square dx. Now I will use this and form three different integrations. So this is equal to integral x square dx plus 2 integral 1 dx. Because it's a constant, I can take it out of my integration sign. Plus integral of 1 upon x square dx. Okay. Now, which formula will I use? I will use integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. X cube upon 3 plus 2x plus x raised to minus 1 upon minus 1 plus c. So this becomes x cube upon 3 plus 2x minus 1 upon x plus c. Okay. I think now everybody will be happy. Everybody is understood. Perfectly clear. Yes, Tamanna clear, Akshata clear, Apurva clear, Ananta, Asha, Vani, Vidisha, Akruti. Akruti, yes, you had asked for the repeat. Hope it is clear now. Similar to the earlier sum, we are going to do this sum. Okay. Yes, Roshan. Yes, Roshan also clear. Ruhani clear. Deepika Vani. Now, here also we are going to expand the bracket and we are going to find the integral. Okay. So first let us just talk about square root x, x cube plus 2x minus 3. So this is nothing but x cube root x plus 2x root x minus 3 root x. Okay. This is how it becomes. Now I will put it in the indices format. This is what x cube into x raised to half plus 2x into x raised to half minus 3x raised to half. What am I using? A raised to m into a raised to n is equal to a raised to m plus n. Let me not write it here, otherwise some student get confused with that also. ये कौन सी step आ गई बीच में बोलते हैं. Okay, so what am I using? I'm using here, I'm writing it for you here. I'm using a raised to m into a raised to n is equal to a raised to m plus n. Okay. So what will this become? X 3 plus half plus 2x 3 by 2 minus 3x raised to half. Okay. Now once I found this is x raised to 5 by 2 plus 2x raised to 3 by 2 plus 3x raised to half. Now my integral of square root of x cube plus 2x minus 3 dx is equal to integration of x raised to 5 by 2 dx plus 2 integral x raised to 3 by 2 dx plus 3 integral of x raised to half dx. So this will become x raised to 5 by 2 plus 1 . Oh no, this is 7 by 2. 3 plus half is what? 3 plus half is 7 upon 2. Okay, x raised to 7 by 2, x raised to 3 by 2, and x raised to half. So this is 7 by 2. So 7 by 2 plus 1, 2 x raised to 3 by 2 plus 1 plus 3 x raised to 1 half plus 1 plus c. So this becomes 2 by 9 x raised to 9 by 2. 7 by 2 plus 1 is 9 by 2. 7 by 2 plus 1 is 9 by 2. Okay. Plus this is 2, 5 by 2. So 2 into 2 by 5 x raised to 5 by 2 plus 3 into 2 by 3 x raised to 3 by 2 plus c. Okay. And this becomes 2 by 9 x raised to 9 by 2 plus 4 by 5 x raised to 5 by 2 plus this 3 and this 3 will get cancelled. You will have 2 x raised to 3 by 2 plus c. Okay. So just be careful while adding, subtracting. So this is the answer. Yes, Vaidehi, that's best. You watch this video first and then again watch it. That time you try to solve. Okay, that time you can stop the video and then you stop, then you solve, then you check with the answer what I have done. So that's a very good way of studying. Yes. Yes, Varun. Yes, Om also. Tamanna, wait, don't rush. Yes, x raised to 7 by 2. How is it minus 3? Where minus 3? Minus 3, it is given in the question only, no? Minus 3. Oh, okay, okay. Sorry. Yes, thank you for pointing it out. This is minus, not plus. Minus 3, and minus. Thank you. This is minus 3. Minus, and minus. Yes, Kriti Kumari. Now the answers are matching. Nitu, I will see. Okay. Yes, Kriti. Yes, last line. Thank you, Saurabh. Sneha, you have to practice, This is a topic that you were never exposed to in your school days, differentiation, integration. So it will just take a little time, not much. The other topics like, we did ratio, proportion or set. So some of you or most of us have studied in the 10th also, some parts of it. But this is entirely new. So don't worry. You can cover it up. Only you have to study. 2 into 3 by 2. This is x raised to half plus 1. Okay, x raised to half plus 1. The integration of this becomes x raised to 3 by 2 upon 3 by 2. So then it becomes equal to 2 upon 3 x raised to 3 by 2. Okay, but there was already a minus 3 over there. So that minus 3, when it comes, it cancels out. Yes. Okay. Now let us do these sums. Now the exponential. Integral of e raised to 3x plus e raised to minus 4x dx. Okay. So what is here? Integration of e raised to ax dx is equal to e raised to ax upon a. This is equal to integral of e raised to 3x dx plus integral of e raised to minus 4x dx. So this becomes what? This is equal to, what is A in this case? A is 3. Okay. A equal to 3 here and A is equal to minus 4 here. Okay. So they are two different ones. So this becomes e raised to 3x upon 3 plus c plus this is equal to e raised to minus 4x upon minus 4. Okay. I'll put this c outside here. Plus c. Okay, this is the plus sign. So e raised to 3x upon 3 plus e raised to minus 4x upon minus 4 plus c will be the answer. Excellent, Mansi. Excellent. Now I have x square upon x plus 1 dx is equal to integral of x raised to n dx upon n plus 1 plus c. And integral of dx upon x is equal to log x plus c. Okay. So we are using these two. Now, there is the simplest method. There are two methods in which I can solve this algebraic portion. The integration portion, there is the formula, there is no problem. Okay. Now, for some of you, this is, I take this x square and I divide it, actual division, x plus 1. Remember, we did it in 7th, 8th standard, same thing. So here I am taking, and I can do this when the power of the numerator is more than the denominator. So x plus 1 is dividing what? X square. So x into x. X into x is x square plus x. Okay, x into 1 is this. Now if I subtract this, minus minus, it becomes minus x. Okay. Now this minus x means what? I have to minus 1 into x will give me minus x. Minus 1 into 1 will give me minus 1. Now this changes sign plus plus. So it becomes 1. So what happens here is my x square upon x plus 1 becomes x minus 1 plus 1 upon x plus 1. Okay, why do we do this? Because the UV rule also you can apply and do, but it becomes a long one. Here, just by simply doing this, I can find the answer. Okay. Now, once I have got this, I will find the integral x square upon x plus 1 dx. This is equal to integral of x plus 1 plus 1 upon x plus x minus 1 x minus 1 plus dx. Okay. Now, what is this equal to? This is equal to integral of x dx minus integral of 1 dx plus integral of 1 upon x plus 1 dx. What is integral of x dx? It is x square upon 2 minus integral of 1 dx is x and integral of 1 upon x plus 1 upon x plus 1 is this. You have to be careful. This is equal to plus log x plus c. Okay, this portion is the thing that otherwise I'm writing x integration of x. I will write it as x x raised to 2 upon 2. Okay, but here that is the case. Okay. Log of x plus 1. Okay. The other way you can do is, I'm showing you the other way also. Okay. Here what I do, I will write x square minus 1 plus 1 upon x plus 1. I will write this minus 1 plus 1. Okay, I will just write this. Instead of writing only x square, I will write this as this. And then I will write it as x square minus 1 upon x plus 1 minus plus 1 upon x plus 1. Okay. Now, remember the formula a square minus b square? A square minus b square is given as a plus b into a minus b. Okay. So I will be using it over here. So I can write this as x minus 1 into x plus 1 upon x minus 1 plus 1 upon x plus 1. Okay. Now what will happen here is x plus 1. This x plus 1 will cancel with this x plus 1 and I'm left with x minus 1 plus 1 upon x plus 1, which is the same as this. Okay, which is the same as this. And so I will have integral of x square upon x plus 1 dx to be equal to minus 1 plus 1 upon x plus 1 plus c. Now, which will have what? This is equal to x square upon 2 minus x plus log of x plus 1 plus c. Okay. So again here, both ways you'll get the same answer, but you only have to remember this portion. Yes, Yamini, there is a typing mistake. Ayush, that only I have done. Okay. So maybe if the PDF is not visible right now, it will be visible after some time. Okay. Yes. Yes, Neha, you should see the session 2-3 times at least. All of you should see the sessions 2-3 times so that if you've missed out on anything, that also you can see. So once this live session is over, you should visit it very soon. Okay, today, tomorrow, in 1 or 2 days. So that because all those things are right in your mind, and that time you take a paper and pen and again try to solve it. Pause the video whenever you are in doubt or it's going a little slow. Okay. आंशिक डिफिकल्ट क्वेश्चन नहीं है ओके दिस इज Janvi, can you put the sum also? I will have to see. Yes, second method, some of you may find this easy. Just adding plus 1 minus 1 can be added. Okay. Yes, Akshata, you've understood? Yes. So both these methods are there. If you are very good in the class 10th when with maths, so that time we had done a lot of algebraic addition, division, multiplication. So that you can use. If not, this is also very simple. This is time saving. Okay. Okay. Yes, Saurabh, I will do that. Yes. Let us take a break now and then we come back in 10 minutes and then we will solve this. This is a little heavy duty topic, so I take a break of 10 minutes because like in case of logical reasoning or sets and functions, we only take a break of 5 minutes. But here we take 10 because so whatever you have written down in your notebook, whatever you tried to solve, just go through it, okay, and let me know. Okay. Ashok, break le le. Welcome back, all of you. Jannavi, this is page 8.26. See, x plus 1 upon x. Same way we have solved. Okay. Here they have expanded, so they have not written over here. Okay. So directly you have x square. So this is same thing as x plus 1 upon x the whole square, and it becomes x square plus 2 plus 1 upon x square. Okay. And they have directly put it over here. So you feel that the method is different. Then even here, the next sum, root x, same thing they have done, x raised to 7 by 2. So how did they get this x raised to 7 by 2? That is nothing but x raised to half into x raised to 3, which is equal to x raised to 3 plus half, which is equal to x raised to 7 by 2. Okay. Now this sum. Okay. Here also they have done the same thing. I have showed you both methods. Here they have done only -1 plus 1. Okay. So if you can remember, the best thing. But if you can't remember, does not mean you won't be able to solve the sum. Okay. If you can remember this step, just add -1 plus 1 in the numerator. Okay. If it is plus 1, what happened? What would have been the case if it has been x square upon x plus 3? Then you will have to x square minus 3 plus 3 upon x plus 3. Okay, so depending on this number is going to change. Okay, if you know that, if you are able to do the 100%, this is the simpler way. But if you don't know, or if you can't remember that time, you can do division. At least everybody, every one of us knows division. So in that time, I will do this. Okay, this is the simplest and the easiest way to do it if I don't remember this method, plus minus 1. Okay. Now in the next sum, what is happening? They are doing the actual division, right? Here, see, by simple division, they are saying. In this sum, they have pointed it out that you need to be able to divide. So I have done this method for all the sums so that you have both the methods with you. Okay? Janvi, is that clear? Sriraj, I can't hear you, beta. You have to just put it in the chat box. 8.26, there is which second sum? Yes, Janvi, they have directly taken 7 by 2. So when you are studying, how do you know where the 7 by 2 came from, right? That is not a method. They have just skipped the steps. They can't keep on writing all. No? So that is why they have done this. This into this gives you this. This into this is going to give you 3 by 2. And then this, then square root into 3, this is going to give you x raised to half. Is it clear? Yes, clear? Now, as we were talking, we are going to use this, the method of division. X cube by x square minus 3 x plus 2. Now this is x cube. So I must multiply with what? x square. X square into x will give me x cube. X square into x gives me x cube. X square into 2 will give me 2x square. Minus, this get cancelled. 5x square minus 2x square is 3x square. This minus 3, I bring it down, it becomes minus 3. Now I need 3x square. I need 3x square, so this will be equal to plus 3x. 3x into x gives me 3x square. Now 3x into plus 2 will give me what? Plus 6x. So I have to write it plus 6x. Now this minus. Now this minus 3 will come down. Minus 3. This becomes minus 6x. Okay. Now what will happen? I have minus 6. So this is equal to minus 6. Minus 6 into x gives me minus 6x. Minus 6 into 2 will give me minus 12. Now I change sign. So this plus 12 minus 3 gives me 9 and this cancels. So remainder. This is the quotient. And this is the divisor. So therefore, integral of x cube plus 5x square minus 3 upon x plus 2 dx now becomes equal to integral of x square plus 3x minus 6 plus 9 upon x plus 2, this whole thing dx. Okay. So quotient plus remainder upon the divisor. Now this is equal to integral of x square dx plus 3 integral of x dx minus 6 integral of 1 dx plus 9 integral of 1 upon x plus 2 dx. What is the integral of x square? It is x cube upon 3. This will be 3 into x square upon 2 minus 6 into integral 1 is x and plus 9 integral of 1 upon x is equal to log of x plus 2 plus c. This is correct. X cube upon 3 plus 3x square upon 2 minus 6x plus, yes. Okay. Ayush, which language do I know? Okay, please explain fifth one. Neetu? This fifth one again, you want, Neetu, you want this to be explained again? Yes, Saronia understood, Asha understood, Mansi has understood. Sneha, very good effort on your part. Tanvi is saying clear. Okay. Okay. So what do? I do the actual such sums where the power of the numerator is more than the denominator. I can go in for either this minus 1 plus 1 type of thing where it is possible. When it is not possible, like in this case, it is not possible. So what do? I use the actual simple division method. I divided the numerator with the denominator. I got a quotient, I got a remainder, and I wrote it down, and then I integrated each term separately. Now let us go to the other method, which is known as method of substitution. Yes, Tamanna, Akshata, Vidushi, Apurva, Vani. Neetu, understood? Anshika, now you've understood? Okay? Okay. See here, because this numerator, see this is cube, this is x raised to 1. So what I have done is, I have done the actual division. X square into x is x cube. Then x square into 2 is plus 2x square. And then I brought this minus 3 down. Then I again solved. But here remember 3x into 2 is 6x. So I have to write it separately because it will not come under minus 3. It's not a number. It is an expression 6x. And then I found the remainder and then I wrote down this is my quotient portion, this is my remainder, this is my divisor, and I have expanded and I have found the value. Okay. Now crystal clear, Akshata? Yes. Amar, clear? Now what happens is, like it was a plus b whole square or a cube, a plus b whole cube, then you have the formula. Now this sum can also be solved when we do statistics. That time you will be able to know a plus b raised to n, where that expansion is also there. But for present purposes, we are going to use the method of substitution. So what do I do is, let 2x plus 3 be equal to t, say. Okay, you can use any alphabet. Differentiating on both sides, we get 2 dx, okay, 2 dx plus 0 is equal to dt. Because differentiation of a constant is 0, okay. So I am differentiating. Okay, so remember this is not integrating, I am differentiating. So how much is dx equal to? Dx is equal to dt upon 2. Okay. Why I have done the differentiation? Because this value for dx I have to again substitute in terms of t, and that is why we do it. Now integral of 2x plus 3 raised to 7 dx will be equal to, now I'm going to write in terms of t. 2x plus 3 is t, so it will be t raised to 7. Instead of dt, I will have dx, I will have dt upon 2 into dt upon 2, which is equal to 1 of integral t raised to 7 dt, which is equal to 1 half t raised to 8 upon 8 plus c. Okay. T raised to 7, n is 7, 7 plus 1, 8 upon 8. This is equal to 1 upon 16. 2 into 8 is 16. T raised to 8 plus c. Now, resubstituting the value for t, we get integral of 2x plus 3 raised to 7 dx is equal to 1 upon 16 2x plus 3 raised to 8 plus c. Okay. Okay, I'm going very slowly so that each one of you is able to follow each step, because each sum is so unique. It is not one type of sum that you keep on doing the same thing over and over again. So I'm taking every type of sum, and this in every type of sum also you could do that. Yes, Mansi. Palak again. Okay. Integral of 2x plus 3 raised to 7 dx. Okay, now because this is raised to 7, it is not raised to 2, because I have a formula for a plus b whole cube, I have a formula for a plus b whole square, but I don't have it. Okay, this formula I don't have. So what I do is I say substitute. What are the steps? Substitute, find dx, put in integral, solve, resubstitute, get the answer. Okay. So first step is substitute. What do I substitute? Let whatever is here inside this bracket raised to, okay, that you, depending on each question, you will be able to find out. 2x plus 3, let this be equal to t. Differentiate on both sides. Okay. This is step 1 I have done. Step 2 is find dx. Differentiating on both sides, 2 dx will be equal to dt. What happened to the 3? Differentiation of a constant is always equal to 0. Okay. So dx is dt. So how much is dx? It is equal to dt by 3. Okay. Put it in the integration. So my integration of 2x plus 3 raised to 7 dx is equal to, instead of 2x plus 3, I'm writing t. So t raised to 7, instead of dx, I'm writing dt upon 2. dt upon 2. Which is equal to 1 upon 7, 1 upon 2, integral t raised to 7 dt. This I'm using the formula here, n is equal to 7. So this is equal to 1/2 of t raised to 8 upon 8 plus c. Because I'm using integral of d raised to n, x raised to n dx. Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So this is equal to 1 upon 16. Where did I get this 16? 2 into 8. What is t? 2x plus 3 raised to 8 plus 6. Okay. And you can always watch the videos again. Okay. Especially for differentiation, integration. You watch them over and over again. And whenever you watch them, just press the like button also, so that more students will come to know that this is a good video. Okay. Chanchal, which 3? 3, I told you, 3 is a constant. Okay, Chanchal, the derivative of a constant is 0. Okay, derivative. We are differentiating on both sides. So, it is 2 dx plus 0 is equal to dt, as 3 is a constant. And d by dx of a constant is always equal to 0. Understood, Chanchal? Yes, Akshata? Crystal clear? Okay, you can always refer to how much weightage each chapter carries on the website. Okay, you can see the PDF over there. Okay, now let us try it again. Okay. Let, what is the first step? Substitution. X square plus 1 be equal to t. Differentiating on both sides, we get 2x dx plus 0 is equal to dt, because differentiation of 1 is 0, or x dx is equal to dt upon 2. X dx is equal to dt upon 2. Why I have written this is because this is in terms of x square. And in the numerator, I have x cube. So this is the most important step. And that is why I say for integration, you need to practice more. X cube is written as x cube dx why is it d coming down? X cube dx, that is there in the numerator, x cube dx. I'm going to write it as x square into x dx. X square into x dx because I have the formula for x dx. Okay. So this is the most important step here. Therefore, integral of x cube dx upon x square plus 1 whole cube is written as integral of x square into x dx upon x square plus 1 whole cube. Instead of x dx, instead of this, what am I going to write? dt by 2. Instead of this, what am I going to write? T cube. And for this, what am I going to write? I'm going to write t minus 1. Okay. Now, how? Let us talk about it. Now, I have x square plus 1 is equal to t, right? So, how much will x square be? T minus 1. Okay. This x square t minus 1. And x dx, I'm writing dt by 2. And denominator x square plus 1 that we have already taken in the first step. So my integral x cube dx upon x square plus 1 whole cube now becomes, this is equal to t minus 1 upon x square plus 1 whole cube is t cube. And instead of dx, I am writing dt by 2. dt by 2. So this is equal to what? Integral of 1 upon 2 t minus 1 upon d cube dt. Okay. Now this is equal to 1 upon 2 integral t upon t cube dt minus 1 upon 2 integral 1 upon t cube dt. Okay, I've just expanded this. I expanded this one integral into two parts. Okay, which is equal to, now t upon t cube is 1 upon this 1 t upon t cube means 1 upon t square dt minus 1 half. This is equal to integral 1 upon t cube dt, which is equal to 1 upon 2 integral t raised to minus 2 dt minus 1 upon 2 integral t raised to minus 3 dt. Okay. Just remember these signs are very important. So what do I get? This is equal to 1 half. T raised to minus 2 plus 1 is t raised to 1 minus 1. And here you will have t raised to minus 3 plus 1 is t raised to minus 2. Okay. One upon t raised to this is equal to, after integration, this becomes t raised to minus 1 upon minus 1 minus 1 half t raised to minus 2 upon minus 2 plus c. Okay, integration will give me this much. Now t raised to minus 1, which is equal to 1 half with a minus sign. What is t? I will resubstitute. T is what? X square plus 1. This is equal to x square plus 1. And this minus into minus becomes plus. So this will become plus 1 upon 4 because this 2 is going to multiply with this 2. And t raised to minus 1. This is raised to minus 1 upon 4 x square plus 1 raised to minus 2 plus c. So I am going to write this as 1 upon 4 x square plus 1 whole square minus 1 upon 2 x square plus 1 plus c. Is that clear now? Yes, this is the right answer. Crystal clear? Yes, Priya? Priya, okay. What is the question? X cube upon x square plus 1 whole cube. Okay, dx. What am I going to do? Put x square plus 1 is equal to t. Differentiating on both sides, I get 2x dx is equal to dt. Okay. Most important step here is writing this as x square into x dx. Okay, that is the most important part. Other than that, everything is solvable. X dx is equal to dt upon 2. Now x square plus x upon x square plus 1 whole cube. Now I substitute over here. This is equal to what? Now x square plus 1 is equal to t. X square plus 1 is t. How much is x square? X square is t minus 1. Okay. This also I need. X dx is equal to dt upon 2 also I need, and this also I need. So these three things I substitute over here. Instead of x square, what do I write? T minus 1. So t minus 1. Instead of x dx, what do I write down? Dt by 2. Dt upon 2. Upon, why does this happen? Upon x square plus 1 whole cube, x square plus 1 is t. So upon t cube. And this is an integration sign. Okay, integration of this. So what do? I take this 2 outside the integration. This is 1 half integral t minus 1 dt upon t cube. Okay. So this is equal to 1 half. Now t upon t cube, which is equal to integral of t upon t cube dt minus 1 half integral 1 upon t cube dt. Now t upon t cube is t square. 1 upon t square. And what is this? 1 upon t cube. So this is equal to 1 half integral t raised to minus 2 dt minus 1 half integral t raised to minus 3 dt. Now what is the formula, general formula? X raised to n dx is equal to integration will be x raised to n plus 1 upon n plus 1. This is plus 1 plus c. Now how much? T raised to minus 2 will be t raised to minus 1 upon minus 1, 1 half into plus, no, not plus, minus. minus 1 half t raised to minus 2 upon minus 2 plus c. Now this is 1 half with a minus sign. So this is minus 1 half t raised to minus 1 plus 1 by 4 t raised to minus 2 plus c. So what do I get? I have minus 1 by 2t. I bring this t raised to minus 1 because I know t raised to minus 1 is nothing but 1 upon t. So plus 1 by 4, 1 upon t square plus c. So resubstituting t as equal to x square plus 1, I will get this is equal to minus 1 upon 2 x square plus 1 plus 1 upon 4 x square plus 1 whole square plus c. Now have you understood? Okay. And because there is a minus sign in the first term, so what do? I will write it as 1 upon 4 x square plus 1 whole square minus 1 upon 2 x square plus 1 plus c. Absolutely clear, Apurva, Ruhani, Vidushi, Saloni, Vani. Last line. Which last line? This one? Yes, Om, we will be doing definite integral also. Yamini also understood. Sneha. No, it is not applicable, Sandhya, to t cube. Okay. It is only applicable when the power of t is 1. Yes, Priya, this type of sum can come. Those are simple sums. Because I'm explaining it slowly, it looks like I'm taking a lot of time, but directly also you'll be able to solve. Yes, Amar, Shama, Priyal, Punitha. Okay. Method of partial fractions. Okay. When this type of sums are given, where the power in the numerator is less than that of the denominator. Okay. If it is more, then I can use the simple division method. If it is not, then I will be able to do this in this manner. Okay. So I will have to use the partial fraction method. When do I use the division method? I'm using the division method when the numerator power in the numerator is more than the denominator. When the power of the numerator is less than the denominator, I will use the partial fraction method. Now 3x plus 2 upon x minus 2 into x minus 3. Now this is written as this is equal to integral of a upon x minus 2 dx plus b upon x minus 3 integral dx. Okay, so now what we have to do is I want to find the values of a and b. So what do I do here? 3x plus 2 upon x minus 2 into x minus 3 is written as a upon x minus 2 plus b upon x minus 3. I cross multiply or find LCM. Okay, find it. Whichever method you remember. So this is going to give me a into x minus 3 plus b into x minus 2 upon x minus 2 and x minus 3. Can you see on the left hand side and the right hand side the denominator are the same? So I can remove those denominators. So what am I going to be left with? I'm going to left with b 3x plus 2 on the left hand side. This is equal to a into x minus 3 plus b into x minus 2. Okay. Now I will group the the terms with x together and the group the terms without x together. So this is becomes a plus b into x, because this is ax and this is bx, uh, minus 2 minus 3a minus 2b. Okay, this together. And this is equal to 3x plus 2. I am equating the terms. So what is the coefficient of x? 3. What is the coefficient of x? X plus a plus b. So a plus b is equal to 3. And what will happen? Minus 3a minus 2b is equal to 2. Okay, because I'm equating the non-x terms together. I can solve this using simultaneous method. Solve using simultaneous method. I will get a as minus 8 and b as 11. Okay. I've got a as minus 8 and b as 11. Now I will substitute here. Okay. I will substitute here a as minus 8 and b as 11. So I will get integral of a upon x minus 2 dx plus integral of b upon x minus 3 dx is equal to minus 8 integral 1 upon x minus 2 dx, and this is 11 plus 11 integral 1 upon x minus 3 dx. Now remember 1 upon x, integral of 1 upon x dx is equal to log x. So this becomes equal to minus 8 log x, log of x minus 2 plus 11 log of x minus 3 plus c. This can be written as 11 log x minus 3 upon, no, okay, this is the answer. Okay, no need to simplify further. If at all there is a reason, then you can use log of m upon n is equal to log m minus log n, if there is a need, but usually you'll be able to find the answer this way only. Okay. Now these are some of the formula. I have put it over there. You just have to look at them, learn the formula. Okay, so direct question only if you get, but for that, you must know the formula. There's nothing for me to solve. I can show you that this find the difference integration of x square minus 25. But if you don't know the right hand side, it's of no use. Okay, so you need to know these formula. Okay. And even this square root of x square plus a square, square root of x square minus a square, that also you need to do. Now coming to an important part, that is the UV rule. As we did with the differentiation, I always find it easier to remember in words. So u is my first function and v is my second function. Okay. So integral of product of two functions, u and v. Integral of, this is used for product of functions. Okay. So integral of u is first function into integral of second function minus integral of derivative of first function into integral of second function dx. Okay. If I say u to be the first function and v to be the second function, then I remember the UV rule as equal to first function into integration of second function minus integral of derivative of first function into integral of second function plus c. Okay. Here it means in UV rule, this is first stage of integration, and then again this will come. You will again have to integrate. So you must remember that in such type of sums, you will not get the answer at the first stage, but you have to always do the second stage. At least 2 stages are there. There may be more also, but at least 2 stages are there. And for that, you must also know here what is called as the ILATE. ILATE. So you have to follow this this acronym, so that what will be your first function and what will be your second function, you will decide by this. Out of this, first is not there in your syllabus. This is your inverse trigonometric function. That is also not there, and t is also not there because it's the trigonometric function. So what you are left with is a, l, a, and e. Means what? If there is a choice between a logarithmic and an algebraic function, then you must first have u as your logarithmic function and v as your arithmetic function. Or you have exponential and logarithmic, again the same thing. Logarithmic will be your first function and exponential will be your second function. Okay, so this is what L stands for logarithmic, A stands for arithmetic, algebraic, and E stands for exponential. Okay. So what is my rule? L, A, E. Now here, x e raised to x. What is x? X is an algebraic function. What is e raised to x? It is an exponential function. So x is written first. It is written first. That is your first function. E is written second. It is your second function. Okay. Second function. Okay. First function and second function. A and E. So is that okay? Yes. Algebraic should come first and exponential should come second. So this order that they have given in the question is correct. What happens if the order is incorrect? You can always write it. Okay. You can always multiplication, right? I can write 2 by 3, 2 into 3 or 3 into 2. It will not make a difference, right? So you can change. So x e raised to x can be written as this. So what is my integral of x e raised to x dx? First function is x into integral of second function minus integral of derivative of first function d by dx of x into integral of second function e raised to x dx, and this whole thing is dx. This is integral and this is differentiation. Okay, so I may even put it this way. So whatever is in the red bracket, you have to solve first and then you in the end differentiate, integrate. Now this is equal to x. What is the integral of e raised to x? E raised to x. Okay. Minus d by dx of x is 1. So again, integral of 1. What is the integral of e raised to x dx? It is e raised to x dx plus c. Now this is equal to x e raised to x. Integral of e raised to x is again e raised to x plus c. Okay. So you can expect this type of simple sums where, they're just checking whether or not you know the UV rule instead of having a very complicated thing, because you may see in your class 12 books, or you may see in some very, very long time ago papers, because that time it was written. Okay. So, and but even like MCQ style, you will not get very huge sums. This is a very simple one because you know the derivative of x, you know the derivative of e raised to x, you know the integration of e raised to x. So it becomes very simple to calculate. Okay, this is a very important 14th I will do first. Okay, this because this is a very popular question, not only here but also in your board exams. Those who have already given know it. If not, those who are still in 11th, you can benefit from this. Integral of log x dx. Okay, directly you don't have a formula for log x integration. Like for derivative I have d by dx of log x is 1 upon x, but for integration I don't have a direct thing. Okay, so I have LAE. Okay, so what I do is I find this. Okay, I know the derivative. Okay, so what happens? L comes first, then E. So I'm going to write this as, this is the most important step. Just be careful with this. This I'm going to write it as integral of log x into 1 dx. Okay, this one is the most important thing. Okay. So this is equal to what? Now, what is my u? Which is equal to the first function, which is equal to log x. What is my v? Which is equal to the second function, which is equal to 1. Okay. And what is the formula? Integral of uv dx is equal to first function into integral of second function minus integral of derivative of first function into integral of second function. Okay. So first function is 1 is log x into integration of second function, that is x. Integral of 1 dx is x minus integral of derivative of first function. Derivative of first function is 1 upon x. What is integral of first function? And integral of second function, integral of 1 is x dx. So what will happen? This x will cancel with this. So as I told you in UV rule, you will have to integrate at least 2 times. So this is log x into x minus integral of 1 dx is x plus c. So this is equal to x log x minus x plus c. Either you will get the answer like this, or you will get x log x minus 1 plus c. Okay. So this is the case. Application. Okay, find the equation of the curve where slope at xy is 9x and which passes through the origin. Okay. So what is given to me? Slope. Remember last time we talked slope, gradient. What does it mean? It implies derivative. So what I have, dy by dx is equal to 9x. Okay. Derivative is written as, slope is written as dy by dx is equal to 9x. So I will write dy is equal to 9x dx. So this dx I take it on to this side. So all the y are on one side and all the x are on one side. Integrating on both sides, I get integral dy is equal to 9 integral x dx. So what do I have? Integral dy will be y. What will this be? It is going to be 9x square upon 2 plus C. Okay. Now, which passes through origin? This is a very good hint. So, this curve passes through 0, 0. Original coordinates are 0, 0. So, you will have 0 is equal to 9 into 0 plus C. What does it imply? C is equal to 0. So, equation of curve is y is equal to 9x square upon 2, which implies equation to be equal to 2y is equal to 9x square. Okay. And see, if you plot the curve, it will look like this. So at point 0, 0, it is passing through the origin. Okay. And this is the way it is going to look. Isn't it amazing how just by knowing the gradient, you are able to find the actual curve? Or sometimes when I'm trying to, I already have a curve, like my instrument has plotted the curve, I can find the slope using differentiation. Okay. These are the practical ways in which you could use integration. Okay. This is also important in terms of theory question. E raised to x fx plus f dash x will be equal to e raised to x fx. Okay. And this one, integral of f dash x upon fx dx is equal to log x log of fx. Okay. The last important part is integral and definite integral. These are some of the properties, like if I have integral from going from a to b, definite means what? And the top value and the bottom value. A is the bottom value, b is the top value that x can take. What can take? X can take. Integral a to b fx, it is called as a to b. Okay, because a is at a lower level, b is at a higher level, is also equal to minus of b to a fx. Okay. So this is a very important property. Fx integral of fx x going from a to b is equal to minus integral x going from b to a. Okay. You can also have this as integral a to b fx. I can also introduce one middle point. So this is equal to integral a to c fx plus integral c to b. Okay, I can split it also, fx dx. Okay, I can do that also. Then this is also very important, integral a to 0, 0 to a fx is also equal to integral 0 to a f of a minus x. Okay, a minus x dx. Okay. So, let me quickly take this. Integral 0 to 2 x raised to 5 dx. I know is what? X raised to 6 upon 6. Okay. And now I don't write plus c, but here I write 0 to 2. I'll draw the straight line and 0 to 2. Means what? I'm going to first substitute the value on the top. This is equal to x raised to 6 upon 6 2 minus x raised to 6, not square. Okay, this will give a different meaning. I'll put in the value of x, I will put 2 raised to 6 upon 6 minus 0 raised to 6 upon 6. Okay, because in the second time I'm going to put x value as equal to 0. So 2 raised to 6 is how much? 32 into 2 is 64 upon 6 minus 0. So this is equal to 32 upon 3. So definite integral of x raised to 5 going from 0 to 2, the value is 32 upon 3. What will happen over here? This is equal to, I will do the normal integration, then put in the value. This is equal to x cube upon 3 minus 5x square upon 2 plus 2x. 1 to 2. So this is equal to how much? I put in the value of 2. That is 2 cube is 8 upon 3 minus 5 into 4 is 20 upon 2 plus 4. Okay, why? I put x is equal to 2 minus I put 1. So 1 upon 3 minus 5 upon 2 plus 2. Okay. Now I have to solve this. LCM is 6. This is 16 minus 60 plus 24 minus 2 minus 15 plus 12. And I should solve and I will get the answer. What is the answer for here? It gives you minus 19 upon 6. Okay. That should give you this value. Okay, this is one important question I want to take for definite integrals, because here we are using this property. Integral, we just discussed this property. Integral of fx going from x going from 0 to a can be written as integral of f of a minus x 0 to a. Okay, so now here I have this, so I'm going to write this as equal to, just let me put this. Okay, let I be equal to 0 to 2 x square dx upon x square plus 2 minus x the whole square. Okay, use the property above. I can write this as I is equal to integral 0 to 2. Instead of x, what I'm going to write? F of a minus x. Okay, f of a minus x. So this becomes a minus x the whole square. Instead of x, what am I writing? A minus x upon. Instead of x, I'm writing a minus x the whole square. And this will be 2 minus, this is here a is 2. So this is 2 minus x. 2 minus of 2 minus x the whole square. Okay. So instead of this, I am writing this 2 minus x. So 2 minus, instead of x, I am writing 2 minus x. So which is equal to integral 0 to 2 minus x the whole square upon 2 minus x whole square. Now this plus 2 minus 2, they get cancelled, and what you are left with is plus x whole square will give you plus x square and dx. Now, the most important thing here is, do you notice that this and this denominator are same? Denominator are same. So, adding 1 and 2. Okay, adding wherever I have written 1 and wherever written 2. Adding 1 and 2, I get I plus I. On the left hand side, this is also I and this is also I. Equal to integral 0 to 2 x square dx upon, I don't think there will be enough space to write. Write it in small writing. So on I plus I. Okay. This I plus this I is equal to integral 0 to 2 x square dx upon x square plus 2 minus x the whole square plus, what is written over here? Plus integral 0 to 2 minus x the whole square upon x square plus 2 minus x the whole square dx. Now adding them, I am going to have 0 to 2. What is in the denominator? X square plus 2 minus x the whole square, and in the numerator you have x square plus 2 minus x the whole square dx. Can you notice that they are same? X square plus 2 minus x square plus 2 minus x. So what will I get? This is equal to integral of 1 dx. Integral of 1 dx 0 to 2 is equal to x 0 to 2. So this is equal to 2 minus 0. Answer is 2. Okay, this is a unique sum. So adding integrals so that on the LHS we get 2i. Okay. So now one more very important step is what I have got is 2i is equal to 2. So I is equal to 2 upon 2, which is equal to 1. So answer is 1 and not 2. Sometimes, we get carried away and then we write that answer, but this is the answer. Okay. Yes, ma'am. Crystal clear. You make all concept very easy to understand. Very nice. Yes, Gautam. Very true. Very true. Ayush, minus 8 and 11, you just have to solve the simultaneous equation. Yes, Ruhani. Correct. Yes, Urvashi, enough for today. Yes, it is easy. Yeah, very nice, Sandhya. You don't even realize it. The session is going to end now. Very nice. Yes, Saloni, answer is 1. Very nice. Yeah. Okay, that's all for today. Yes, thank you. Thank you for your patient hearing. Have a great day ahead. Okay, thank you. Ashok?